in this lesson, we're going to now talk about chords and arcs in the circles that we're dealing with. So our objective is I can relate chords and arcs in circles. So just so you know what we're talking about vocabulary-wise, this here, this is listed as a chord. And it's related to this here, which is related as the arc. We're going to talk about the relationship. Arcs are on the circle, the chords are going between 2 points on the circle. So let's talk about what some definitions and also some terms and maybe some formulas that we're going to use. So first of all, we're going to talk about congruent arcs. When you look at a diagram like this, if you've got these two chords congruent, we're talking about now if you're in the same circle, this is what's given to us, or it's even if you've got two congruent circles. If you start there, when you've got congruent chords, then the arcs are congruent. Chords congruent means arcs are congruent if you're in the same or congruent circles. So congruent chords means congruent arcs. All right, we'll use that quite a bit, but you can look for finding if you've got chords involved and also if they're congruent. Now let's talk about perpendicular bisectors and how those relate. We can now look at our diameters and radii in these problems, and if we have a perpendicular bisector, so notice that this is perpendicular and it bisects it, so it makes two congruent segments of that chord, splits it into two congruent ones. So if a diameter or a radius is perpendicular to a chord, then it bisects the chord. And that's going to be very helpful in working with it. So it also bisects the arc, so we can use either the arc or the chord in this problem. Now, very similar to it, if we're starting with a diameter or radius, so a perpendicular bisector so we'll start actually in this case the perpendicular bisector of a chord. So if it comes and bisects it and also is perpendicular, then it is either a diameter or a radius. Now that's helpful because oftentimes we use, for instance, a radius to find area or arc length or different measures. So if we know that it's perpendicular to it and bisects that chord, it's going to be that diameter or radius. Okay, so similar to that when we talk about those sorts of things, we can talk about equidistance. So if we have in the same or two congruent circles, if we've got the distance to those, so distance is measured by drawing a perpendicular. If that perpendicular, if we've got those two segments congruent to each other, then they're going to be, those being equidistant, then those chords are going to be congruent. So if in the same or congruent circles, two chords are congruent, if and only if, meaning it's both the theorem and also its converse, if and only if they are equidistant from the center. So that means that this chord and this chord are going to be congruent because they're equidistant from it. Or if the chords are congruent, then the these two smaller segments will be congruent. All right, let's try some problems. Let's do these problems at the bottom. Using this information, take a moment and just make sure you write down the information listed in these problems, and then we'll start on them. Now that hopefully you paused the video and we're able to write that information down, let's go ahead and solve these. Okay, so for this first one, what we've got is that we've got this arc being 127 degrees and this arc 127 degrees. If the arcs are congruent, then these two chords are congruent. So I'm going to set 5x equal to 3x plus 6. This chord there. Solve by subtracting 3x from both sides. You get 2x equal to 6. X is equal to 3. And we're asked to find x in this problem. The next one, what we're going to do is use the fact that that's perpendicular, and we're going to use this radius. This is a very common practice that when we do problems like this, sometimes what you will do is you will draw in a radius to help you solve the problem. So this radius from here to here is 6 units. We could use that, but I'm going to use it from J to P. This is also 6 units. From the center to J gives me that 6 units. Okay? What I also have here is that I'm going to add a little piece of information that's not written on this diagram. This side is going to be a 5. So from J to Q is 5. We're going to find now PQ, and I'm going to call that X. So now, because I have this side here is 5 given to me, I'm trying to find this side. I draw in the radius of 6. I now use the Pythagorean theorem, x squared plus 5 squared equals 6 squared. Solve this, x squared plus 25 equals 36. X squared, when I subtract both sides, I get 11. Take the square root of both sides. We take just the positive square root in this case. So the square root of 11 is my answer for x. Okay, let's go ahead and circle that. Okay, and then this last problem here, scroll down just a little to see it. Okay, for this one, notice that we're given that the length between the center and these chords is the same. It's both 5 units. That means that these chords are going to be congruent to each other. So if GH is equal to 9 and KL is equal to 4x plus 1, I can now set those equal and find x. So let's put 9 equal to 4x plus 1. Solve by subtracting 1 from both sides. You get 4x equal to 8. Divide by 4 and you get x equal to 2 for the answer. So solving problems involves, in this case, trying to relate the chords to the arcs. Sometimes you'll have congruent chords, sometimes congruent arcs. Sometimes you'll want to draw in a radius and then relate all that information in to solve problems given the information in the circle. Let's do some algebra review. Let's go back and look at substitution and elimination methods from algebra. If we're given what's called a system of equations, which means there's 2 variables in the problem and we've got 2 equations, that's called a system of equations. And what we want to do in this objective is to solve that system of equations. The first thing to do here is what we call substitution. Substitution means you get one variable by itself. So in this case, in this first problem, I'm going to go ahead and subtract 2y from both sides. So here I'm going to take and make x equal to 11 minus 2y. Now what's nice about that is when I get that I can take this 11 minus 2y and it can be substituted in for x in the other equation, hence substitution. So I'm going to have 4, take out the x, put it in parentheses, minus y equals 17. I'm going to put this 11 minus 2y in that place of where the x was, and now I've got an equation with just one variable. I'm going to solve it. So 4 times 11 is 44. 4 times 2y is 8y, minus y equals 17. Negative 8y minus y is negative 9y. I'm going to subtract 44 from both sides. 17 minus 44 gives me a negative 27. Divide by negative 9 on both sides, and you get y equal to 3. Now, we can't stop there. We got what y is. Let's put that back in to get what x is. So going back here, we get that x is going to equal 11 minus 2 times 3, that y, so substitute back in. So x equals 11 minus 6, which gives me 5. So my answer, we often put as an ordered pair, 5, 3 for our answer to x and y. Now, elimination is a little different. Elimination is when it's not quite as easy to get one of the variables by itself. If you look at this problem here, notice 3x minus 2y, if I divide everything by 3 or 2, I get fractions. And here, if I divide by 7 or 2, I get fractions. So what we want to do is use what's called elimination, where we're going to look at these and say that the y's are opposites of each other. So if this equals that, and this equals that, since they're equal, I can add them, equal things you can add. And so what I'm going to do here is just add straight down. And when I add these straight down, I get 3x plus 7x is 10x. Negative 2y plus 2y, they're gone, no more y's. 7 plus 3 gives me 10. Divide by 10 on both sides, you get x equal to 1. Now we use substitution and put that back in. I'm going to put that back into the first one. So 3 times 1 minus 2y equals 7. I'm going to subtract 3 from both sides. Negative 2y equals 4. Divide both sides by negative 2. You get y equal to negative 2. And so my answer here is 1, negative 2 for my x and y solution. So that's how you can solve a system of equations, which means 2 variables, 2 equations, and we're going to solve it to find the x and the y by either substitution or elimination, our algebra review.